This video is for lesson 33-3, Spheres and Solids of Rotation. Learning goals are to discuss the properties and cross-sections of a sphere and to identify three-dimensional objects that are created by rotating a two-dimensional object. First, let's discuss a sphere. A sphere is the set of all points in space that are a given distance from a given point. On a flat surface, the set of points that are a given distance from a given point is called a circle. Now think about in three-dimensional space. The set of points that are all equidistant from a center creates a sphere. A sphere is round, like a basketball or the Earth. Question 1. Let's think about what the cross-sections of a sphere would look like. Imagine slicing through a sphere and then turning it in your hand and looking at the shape that you would see. What would that shape be? It's a circle. If you slice through the equator of a sphere, the cross-section would be the largest possible circle that can be created from that sphere. As you slice through different locations in the sphere, you can change the size of those cross-section circles. So question B, where is the largest of the cross-sections? We said that that would be located at the equator of the sphere. In the drawing of the sphere on the screen, that's represented with the dashed line. Question C, where is the center of that largest possible cross-section circle? It is the center of the sphere. Number 2, the figure shown is a sphere. Write a definition for a chord of a sphere and draw and label such a chord. Remember that a chord in a circle goes from one side of the circle to the other. So if we put a dot somewhere on the sphere and put a dot somewhere else on the sphere and connect those together, that's a chord. Here's our definition. A chord is a segment with endpoints on the sphere. Now question B, write a definition for diameter of a sphere and draw and label a diameter in the diagram. The diameter is a chord that goes all the way across the sphere. There are many of them that could be drawn, but one way to draw it is to put a dot here, and draw so that you're going through the center of the sphere. That is one of an infinite number of diameters. And here's the definition for diameter of a sphere. It's a chord that passes through the center of the sphere. Question C, write a definition for a tangent line to a sphere and draw and label a tangent line. On a circle, a tangent is a line that touches the circle in exactly one spot. We can do the same thing on our sphere. Let's find a dot on the sphere and then draw a line so that it barely grazes the sphere at that dot, so that it only touches the sphere at that one dot. That's a tangent line. And here's the definition of tangent line. A line that intersects the sphere only once. A tangent plane would be a plane that intersects the sphere only once. The word plane refers to a flat surface. Imagine taking a basketball and sitting it on the floor. It would touch the floor at exactly one point on the ball. The floor would be tangent to the basketball. Question D, what's true about a tangent plane and the radius of the sphere at that point of tangency? We studied this with circles. Here is a drawing of a circle. Here's a tangent line brushing up to that circle at one dot only. Here's the center of the circle, and here's a radius drawn to that tangent line. What was this angle again where the radius touches the tangent line? It's a 90-degree angle, and that's also true for a sphere. So the answer to question D is that it forms a 90-degree angle. On to the next page. Solid objects can often be formed by taking flat two-dimensional objects and rotating them in a circle, spinning them around in a circle. You can create a sphere by rotating a semicircle shape around a line. As you spin this semicircle around the line 360 degrees, it traces out a sphere. Try to imagine doing this in three-dimensional space right in front of your body. Can you visualize what's being discussed here? Rotating a plane around a given axis line forms a three-dimensional figure known as a solid of rotation. So one example of a solid of rotation is a sphere. Number 3, what solid of rotation is created by rotating a rectangle around an axis line? You have to imagine this happening right in front of you. Imagine a flat rectangle. You could put your hand up right in front of your face and look at the back of your hand. Then rotate your hand around a vertical axis. What is that tracing out? It creates a cylinder. On to number 4. Draw and name the solid that's created by rotating a triangle around the x-axis. Again, it's hard to imagine this. You've got to try to visualize what's happening. We're going to take this triangle and rotate it around this axis line back to where it started. It's going to create a cone. To draw a cone, you create an oval to make the illusion of a circular bottom, and then draw it out to a point. A cone is what's created when you spin a triangle around a line. Number 5, describe how figure B is created from figure A. So in figure A, we have a flat six-sided shape called a hexagon. Notice this arrow indicating that we want to rotate this around that vertical line. That would create this object here, which is drawn on flat paper, but it's intended to be a three-dimensional object. You have to imagine what this looks like as a three-dimensional solid object. It says describe how to make it. We simply need to say that we're going to rotate figure A around a vertical axis line. Another part of the question says to name the three-dimensional figures that make up figure B. What's the top of that shape? It's a cone. What's the bottom of the shape? It's a cone. What would you call the middle portion of that shape? It's a cylinder. Next, go to the check your understanding question, number 7. What is the ratio of the measure of a radius of a sphere to the measure of the radius of its great circle? The word great circle refers to the largest possible circle that can be drawn around a sphere. Earlier, we had used the word equator for that. So we have a sphere like the one drawn here. Let me put a dot in the center of that sphere and then draw in a radius of the sphere right to that spot there. Do you notice that that radius is also the radius of the circle that goes around the middle of the sphere? So they have the same radius. The answer to number 7 is a 1-to-1 ratio. Let's summarize this lesson. We discussed a three-dimensional shape called a sphere and talked about the cross-section of a sphere being a circle. The largest possible circle that can be drawn around a sphere is called its equator, or its great circle. We also talked about how three-dimensional shapes can often be created by rotating two-dimensional shapes around an axis line. These are called solids of rotation.